Example 12. For the following function, find A, the critical numbers, B, the open intervals where the function is increasing, and C, the open intervals where the function is decreasing. Our function is f of x equals x times e to the negative 3x. This is going to be a product rule where our first function is x and our second function is e to the negative 3x. So our first function prime is 1. Our second function prime is e to the negative 3x times negative 3, which I will write negative 3e to the negative 3x. Since it's a product rule, we have to do first times derivative of second plus second times derivative of the first. So our first is x, derivative of the second, negative 3e to the negative 3x, plus the second, e to the negative 3x, times the derivative of the first, which is 1. And the first thing I notice is that both of these have an e to the negative 3x. So I'm going to factor that out so it'll be easier to work with. E to the negative 3x is taken out, so I have a negative 3 and an x, and here I have a plus 1. So my derivative is e to the negative 3x times negative 3x plus 1. Now e to the negative 3x is never equal to 0 because e is a positive base. It's approximately 2.7. When you raise a positive base to any power, you will never get a negative, okay? And you will never get a 0. So all I have to do is look at negative 3x plus 1 is equal to 0. By solving, I get negative 3x equals negative 1. X is negative 1 divided by negative 3, which is positive 1/3. That's my critical number. And yes, that's in the domain of the original function. There are no restrictions here. Remember, no logs, no square roots, no denominators, no restrictions, okay? As long as those three things are not present, there are other functions that have restrictions, but trig functions, for example, but not in this course. So you're only looking for logs, square roots, and denominators. And we don't have any of those. So our original function has a domain of all real numbers. All we have to do is take our critical number of 1/3, put it on the number line, test a number to the left and a number to the right. And I'm just going to pick 0 and 1. Those are easy enough. So f prime of 0 is e to negative 3 times 0, negative 3 times 0 plus 1. Well, that's e to the 0 times 1. E to the 0 is 1, and 1 times 1 is 1. And 1 is a positive, so this side is a positive number. My function is increasing here. When I do f prime of 1, I get e to the negative 3 times 1 times negative 3 times 1 plus 1. Well, that's e to the negative 3 times a negative 2. This is always positive. This is a negative. So this is going to be a negative. And you can get the actual value if you want to. That means it is decreasing on the right side of the critical number. So it increases from negative infinity to 1/3, and it decreases from 1/3 to positive infinity. So our final answer for our derivative was e raised to the negative 3x times negative 3x plus 1, and you could enter that in the distributed form as well. The critical number turned out to be 1/3, it was increasing from negative infinity to 1/3, and it was decreasing from 1/3 to positive infinity.